All right, so we're finally starting 11.3, which is geometric sequences and series. So after this, how many more sections do you think we have? 2, binomial theorem and induction. Yes, so 2 more. I was wondering, do you guys want to have the test on Thursday or on Monday? Or on, no, yours is scheduled when? Monday. Oh, okay. So, we'll keep it on Monday then. Yeah, okay. What is this? Okay. So, let's share the desktop. And it's recording, I guess. 11.3. All right. 11.3 is geometric sequences and series. So yesterday we talked about arithmetic sequences and series. So this is geometric sequences and series. Let's see what's the difference. Yeah. So geometric sequence. So let me write down. This is A first. Geometric sequence is what? Is a sequence in which each term after the first is obtained by multiplying the term by a fixed number. The previous term, sorry. Multiplying the previous term by a fixed number. And the number is called what? Called ratio. Common ratio. Yeah. So this is a geometric sequence. So for example, you have 1, then you multiply by 2, multiply by 2 again, multiply by 2, multiply by 2. And what's the next term? 32, 64, etc. Yeah, so what we have here is ratio. So multiply by 2, multiply by 2, multiply by 2. So the ratio, so R is common ratio is 2 in this case. Yeah, so R is 2. Common ratio. And R, this is AN plus 1 divided by AN. All right. So R is common ratio. Now, what is AN? So this is AN is the nth term. The nth term of a geometric sequence. What do you think the formula will be? So if A1 multiplied by what? R, how many R's? R raised to the n minus 1. Okay? So let's think about it. If you have, why is it R to the n minus 1? Look at this. If I have A1, A2, A3, A4, A5, blah, 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 etc. Yeah. So if I want A5, what is A5? A1 multiplied by how many R's? 1, 2, 3, 4, right? Times R to the 4, isn't it? Okay. So what about if I want A4? So now just say I want A4. So how do I get A4? It is what? A1 times how many R's? So R times R times R, 3 times. So that's why this is R cubed. So that's why this is n minus 1 and not n. Make sense? Yes. So it is 1 less than the n. Yeah. And what is A1 again? Oh, 6 out? Yeah, the first term. Yes. What is R? Yes, common ratio. Okay. So remember, both the arithmetic and geometric sequence has n minus 1. It's just that for arithmetic, it's A1 plus n minus 1 times D. For geometric, is A1 times R raised to the n minus 1. All right. Okay. So let's do an example. Okay. So number 1, find AN and A5. All right. For this one, -4, 12, -36, dot, dot, dot. Okay. So we want to find AN and A5. All right. And then number 2, well, I don't have space, so I have to wait. So what would you do here? Yes. So A1 is equal to -4. And what is the ratio? 12 divided by -4, which is -3. Yes. Okay. Now, AN is equal to A1 raised to the, multiplied by R raised to the n minus 1. So AN is equal to A1, -4 multiplied by -3 raised to the n minus 1. Isn't it? Okay. Now, you could leave it like this, but sometimes I don't want you to get confused because the answers, you are going to simplify these a little bit. Yeah. So AN is equal to -4 times -3 raised to the n times -3 raised to the -1. Isn't it? Okay. Am I doing okay so far? I mean, you're not getting lost? Yeah. So what is -3 raised to the -1? Oh, I was going to. Okay. So what is -3 raised to the -1? What is this? 1 over -3. Yes. So AN is -4 times -3 to the n raised to the 1 over -3. Now, can I combine the -4 and -3? Yeah. So AN is equal to 4 over 3 raised to the -3 to the n. All right. But if you want to leave your answer in this form, it is fine. This is okay. Now, on some of the solutions of your answers, they will write it in this form because this is simplified. Yeah, so to simplify, this is the simplified version. So simplify your answer, then this is the answer. Does that make sense? So, simplified version. Yeah, so this is a simplified answer. All right. Now, let's do another one. Yeah. So, say it again. Oh, A5, sorry. Yes. What is A5? Well, we just have to continue here, don't we? Or we could just substitute here, right? Yeah, let me write it here. So, sorry. So, A5 is equal to 4/3 times -3 to the 5th, isn't it? Oh, to the 4th, yes. N minus 1, 4. So, A5 is equal to 4/3 times, is it 81? Okay, so 4 times 27, 108. All right, so A5 is equal to 108. Because it's 5 supposedly. Yeah, you did. So this is to the 5th, yes, to the 5th. Yeah, it is, yes. So what's the answer then? It's 243, is it? Okay. Yeah, you're right. If you substitute here, yes, it is 8 to the 4th, right? So -243, is it? So -243 divided by 3 is what? -81. So what's your answer? You're right. -3, what is it? 24? Yeah, you are right. Yeah, thank you. I'm glad. Yes? N is 5, right? Okay, good. Let's see. Number 2. So maybe I'll just do this so you can still see it. Yes. Number 2. What about if we have find A1 and R? Okay. So given A3 is equal to 5 and A8 is equal to 1/625. All right. How are we going to answer this? So any idea? What are we going to do? What's the formula that we're going to use? AN is equal to A1 R to the N minus 1. Yes. So A3 is 5. So A3 is equal to A1 R squared. So 5 is equal to A1 times R squared, isn't it? Yes. So this is equation 1. All right. Now, the next one is A8 is equal to A1 times R to the what? 7. So do we know A8? 1/625 is equal to A1 R to the 7. So this is equation 2. All right. Okay. Now, how are we going to solve something like this? We will divide, actually. Division? Okay. So what we will do is divide, well, we have to get rid of A1. So what we will do is divide equation 1 by equation 2. So what we will have was 5 is equal to A1 R squared divided by 1 over 625 is equal to, what am I doing? 5 is equal to A1 over R squared divided by 1 over 625 divided by A1 R to the 7. Right? Okay, so basically we eliminate A1 here. What is A1 divided by A1? Cancel, yes. What is 5 divided by 1 over 625? It's just the same as 5 times 625, isn't it? 3125? Okay. What is R squared divided by R to the 7? 1 over R to the 5th. Yes, that's right. So what is R to the 5th? What is R to the 5th? So R to the 5th is equal to 1 over 3125. Now what is R? Yes, we take the 5th root of both sides, so R is 1 over 5. Yes. Good. How do we solve for A1? Substitute R? Yes. So substitute R equals 1 over 5 to equation 1. So when we substitute R, we have 5 is equal to A1 times 1 over 5 squared. What is 1 over 5 squared? 25? Yes. So 5 is A1 over 25. Then what is A1? 125. Yes. Good. Yeah. Okay. Are we okay? Yeah. Good. Doable? Okay. Now, the sum. And then we will talk about the infinite geometric series, and then we are going to discuss the sample test. You guys have some questions on the sample test? By the way, last time when I emailed you the files, how many files did I email you? Oh, 2 only. So there is no answer for chapter 11. Okay, so I will email it to you today. But I don't have a lot for chapter 11. Okay, it's not a lot. Yeah. So only 2 files. So today I will email it to you again. It's going to say key for chapter 11. Yes. No problem. This one? Yeah. Okay. So we cross multiply here, or you could say, oh, we will multiply both sides by 25. But this is 5 over 1, so you could cross multiply. Why? Because this is R square. Oh, okay. So this is R square. So this is 1 over 5 square, which is 1 over 25, right? Yeah. Good. Stop. Why is it R square? Equation 1 is A3 is A1 times R squared, right? Because n is 3. So if n is 3, what is n minus 1? Yeah. Good question. Thank you. Yeah. All right. So next, let's see. B. The sum of the first n terms So B is the sum of the first n terms of a geometric sequence. So Sn is equal to A1 times 1 minus R to the n divided by 1 minus R. But this is not true for R equals 1. So R cannot be equal to 1. And we could actually prove this. Yeah, this is not hard to prove. But I'm not going to do it today. So this is like the thing you do with Gauss. Yeah? Okay. So what is Sn? So Sn is the sum of the first n terms. What is A1? The first term. So we're talking about geometric sequence here. Do you remember we have two formulas for the arithmetic? Yeah, so this is formula for geometric. And R is the common ratio. So here, everything is for the geometric sequence. All right. Okay. 1 minus R. So, for example, find Sn. Okay, so number 1. 4, 16, 64, 256, that. And number 2, find Sn also. 18, negative 9, 9 over 2, negative 9 over 4, dot. And then number 3, sigma, I goes from 1 through 100 of 2 times 3 to the I. Actually, find Sn is for number 1 and 2. So for number 3, we want to find sigma. I goes from 1 to 100. 2 times 3 to the I. All right. So what you want to do here, so this is a hint here. It's easier if we write the sequence first. So then you know what is A1 and what is R. Yeah. All right. Now, for number 1, how are you going to do it? We need A1 and R. All right. So what is A1? 4. Good. Oh, A1 is 4. What about R? Also 4? Yes. So then what is Sn? It is A1, 1 minus R to the n divided by 1 minus R. So Sn is A1, 4, 1 minus 4 to the n divided by 1 minus 4. So what is this? Negative 4 over third times 1 minus 4 to the n, right? Finish. Good. All right. Can we do anything else here? No. This is 4 to the n. The exponent should be evaluated first. Yeah. Okay. So number 2. How would you do this?
I'm sorry. Why is the whole thing over -3?
Because the denominator is 1 minus r. What is 1 minus r? 1 minus 4. What is 1 minus 4?
Right, but no, what I'm saying is why is it the whole thing? Because you got -4/3 times 1 minus.
Oh, it's the same thing. If I have, okay, let's just say if I have 3x over 2, this is the same as 3 over 2x.
Oh, okay.
Yeah. Yeah, so you could write it like this. You could write it like -4, 1 minus 4 to the n divided by 3. That's what you're asking, right? Yeah, it's the same thing. You're right. I'm glad you asked. Yeah, I know. Sometimes I make you guys confused, but they're the same thing. Okay. Can you answer number 2? What is A1? 18. What is R? -1/2. Okay, so Sn is 18 times 1 minus -1/2 to the n divided by 1 minus -1/2, right? Okay, isn't it? Okay. What is 1 minus -1/2? 3 over 2? Okay. So the top, there is nothing you could do. 1 minus -1/2 to the n. How about 18 divided by 3 over 2? What is 18 divided by 3 over 2? Okay, so this is your scratch here. Oh, do I have space here? So your scratch here. What is 18 divided by 3 over 2? This is the same as 18 multiplied by 2 over 3, which is 12. Yeah. Yes? So this is 12. Let me just erase this one and do it on a different page, okay? Okay, so I have space, scratch. 18 divided by 3 over 2 is equal to 18 multiplied by 2/3, which is 12. So this is 12 times 1 minus -1/2 to the n. All right. Yay? Okay, so this is S then. No, because you have to apply the exponent first. So you cannot combine. That's a good question. Look at these. Which one goes first? Can I add this? Can I change this? No, right? Because the exponent has to be applied first to the -1/2. Well, why don't we find out S10, for example? What is S10? So for each one of these, let's find S10. What is S10? 12 times 1 minus -1/2 to the 10. Yeah. Can you find the value for this problem? So my problem, I'm going to change find Sn and S10. So I just added this. Okay, so for number 1 and 2, we will find both. So here, what is this? Any idea? Okay, so 12 times, open parentheses, 1 minus, and then parentheses again, 0.5 raised to the 10. All right. What did you guys get? Yeah, 11.988. Yes. Did you guys get it? Yeah? Calculator? Okay. So this is for these. Can we do an S10 for this? For number 1? Sorry. Oh, it doesn't look good. But, sorry, this is for number 1. Yeah, what is S10 for number 1? So, -4 times 1 minus 4 to the 10th, this is a big number, divided by 3, right? So, let's see what this is. So, -4 multiplied by, open parentheses, 1 minus 4 raised to the 10. Yeah, divided by 3. So, 1398,100. Yes. So far, so good? This is for number 1. Yeah. Yeah. Calculator? No problem with calculator? Okay. Now, number 3. So, number 3. What was that? I was going to ask you what? Sigma I goes from 1 through 100. This is a big number. 2 times 3 to the I. Oh. So what I'll do here, I'm just going to write down the terms. So how do I write? What does the sigma mean? You're adding, right? Okay. So what is the first term? So when I is 1, what will this be? 6. Okay. When I is 2, what will this be? 2 times 9, which is 18. When I is 3, so this goes from I is 1, I is 2, and when I is 3, what is it? 2 times 3 cubed, so 54. All right. Now, remember what my hint in the beginning? What was my hint at the beginning? Write the terms. So I'm going to write it like this. So the terms or the sequence, 6, 18, 54, So do I know what A1 is? A1 is 6. What is R? 3. Yes. So don't you think it's easier if I write this? Yeah, so this is my hint in the beginning. So hint, write the terms. So there you go, you did it, and you easily see it, right? Actually, this is your R here. Yeah, 3 to the I. Now, what is Sn? Sn is A1 times 1 minus R to the N divided by 1 minus R. Oh, S of 100 is A1, 6, 1 minus 3 to the 100, this is a big number, divided by 1 minus 3. So what is 6 divided by 1 minus 3? -3 times 1 minus 3 to the 100. Can you get a number? This is a big number. So -3 multiplied by, open parentheses, 1 minus 3 raised to the 100. So that's equal to, this is a big number. What was the answer? 1.546 multiplied by what? 10 to the 48. Yeah, it's a big number. Alright. Why do I give you guys big numbers? So that you don't add it one by one. Yeah? Okay. Last one. What about sigma? K goes from 4 to 10 of 2 to the k. Again, what does it matter that k goes not from 1? Well, it actually doesn't matter, but we have to make sure we count what n is. Yeah. So let's see. Let's list down the summation. When k is 4, what do I have? 16? Yes. When k is 5, what do I have? 32? When k is 6, I have 2 to the 6. Is it 64? Yes. Dot. Until the last one here would be 2 to the 10. 2 to the 10 is 1024. Right? Or you can just write 2 to the 10th here. This value is not important. It's just 2 to the 10. All right. Now, so let's write down, remember the hint? So let's write down the terms. So the terms are, what are the terms? 16, 32, 64, and dot up to 1024. Do we know A1? 16? Do we know R? 2, yes. Do we know N? So I need to know N. So 3 things we need to know, A1, R, and N. So what N before was 100. Oh, N. Before N here was 100. What about N here? Yes.
Since k equals 4, would it 16 be A4 instead of A1?
No. It doesn't matter what it is. So it doesn't matter how the summation is written. This is your geometric series.
Okay.
Yeah. So we say that this is A1, A2, A3. But I need to figure out what is N now, since you're not starting with 1. So I need to figure out what is N. From 4 to 10, what is N? Is it 6? 4, 5, 6, 7, 8, 9, 10. So it is 7. Yeah. So you have to add 1. So from 4 to 10, that is not 6, but 6, 10 minus 4 plus 1. Yeah. So remember, the N here, be careful. How do I get 7? This is 10 minus 4 plus 1. Because if you're counting from 4 to 10, let's see. 4, 5, 6, 7, 8, 9, 10. How many of them? 7. Does that make sense? So not 6. Yeah. So you start with 4, right? So 4, 5, 6, 7, 8, 9, 10. I'm using my fingers, but 7. So remember this, the number of terms you have to add. So the higher minus the lower summation, and then you remember you have to add 1. Same thing with the 101. What is, how many terms is between 1 and 100? 100 minus 1, which is 99, and then you add 1, right? So to get this 100, you have 100 minus 1, which is 99, but then you have to add 1. So remember to add this 1. The number of terms is you have to add 1. Yeah, same thing here. 100 minus 1, which is 99 plus 1. You have 100 terms total. Does that make sense? Okay, so S7 is equal to A1, 1 minus R to the 7th, divided by 1 minus R. So S7 is A1. What is A1? 16, 1 minus 2 to the 7, divided by 1 minus 2. Yes. So S7 is negative 16, 1 minus 2 to the 7. So what is this? So negative 16 times 1 minus 2 to the 7. So is it 2032? Okay. All right. Good. Okay. Now, looks like I'm still not done with 11.3. Looks like I won't have time to review. Do you want to change the test to Tuesday? It's better? Because tomorrow I will have time to review. Oh, I mean, on Monday I will have time to review. So Tuesday better? Everybody agree? Unanimous vote? Yeah? Tuesday? Okay. So let's just do it on Tuesday. Yeah, I'm sorry, I was late today. Otherwise, I would have been able to do a 10-minute review. But that's not good, right? Tuesday is better, right? So it's good that I was late. No, that's not the conclusion. I mean, that's not a good conclusion, right? Okay, yeah, Tuesday is fine. Yes. Yeah, but I apologize. I was late today. Okay. Yes. So let's see, it's here. So Tuesday is the test, not Monday. So the next one is C, which is infinite geometric series. So the test is on Tuesday. Test is Tuesday, and which one will it include? Chapter 10 plus 11.1, 11.2. Yeah. All right. Good. And do you know when your final is? Oh, we decided on a Thursday, not a Tuesday, right? Okay. So final is Thursday, what time? 7 a.m. Yes. Oh, okay. Okay. Yeah. So 7 a.m. to 9 a.m. Yeah. Let me see. No, the following week. Thursday, December 15th. The final is December 15th. Yeah. Okay. Is it too early for you? If you want, you can come later because I'm giving another final is 9:30 to 11:30. But you have to let me know if you want to come 9:30 to 11:30. How many people would rather do it 9:30 to 11:30? But don't come late, okay? So you do have to come 9:30. Yeah. Okay. Well, how many? I just want to make sure I have enough seats. 1, 2, 3, 4. Okay. Yes. Okay. Fine. So you don't have to tell me or anything. I'm going to ask you again. But if we have only 5 people, you can come 9:30 to 11:30 a.m. on Thursday, same day, same classroom. Yeah. So you'll just take the final with my other class, which is fine. Okay. Yeah. So the next one is infinite geometric series. Well, I'm going to be there in the morning, and also I'm giving another final, 9:30 to 11:30. So that's fine. Yeah. It's just that if the whole class show up, maybe I don't have enough seats for the other students. All right. Now, infinite geometric series. So let's just say the series goes on forever. So, and it converges, so we have S infinity. This is equal to A1 divided by 1 minus R. Yes? But these only exist when R is in between -1 and 1. All right. Yes? So otherwise, the series diverges. So it only converges when R is between -1 and 1. Yeah. Now, what is S infinity? S infinity is the sum of the terms of an infinite geometric series. Do we know what A1 is? 6S? Yes. You're completely right. What is R? Common ratio. Yes. All right. Common ratio. Yes? Okay. So let me write down a little bit. So if absolute value of R is greater than 1, then S infinity does not exist. So it only exists when R is between -1 and 1. So we say that the sum does not converge. All right. So if it doesn't converge, we say it's divergent. Or yes. All right. So for example, number 1. Find this sigma I goes from 1 through infinity of 3 raised to the 1 over 4 raised to the I minus 1. And then you guys might be surprised too. Suppose I have 1 plus half plus 1/4 plus 1/8 plus ... So you will be surprised too. What is the answer? Yeah. Maybe let's do number 2 first. All right. I'll make sure my okay. All right. So how do we do number 2? Okay. So answer. Do we have an A1? Yes. What is it? Do we have an R? Yes. So does the S infinity exist? The sum of the infinity? It exists? Yeah, okay. So S infinity is equal to A1 divided by 1 minus R. So I have to write down. Here R is between -1 and 1. So yes, right? So this is A1, 1 divided by 1 minus half. What is 1 divided by half? 2, yes. Oh. So it's weird, isn't it? If you add 1 plus half plus 1/4 plus 1/8 plus 1/16 plus 1 over 32 plus 1 over 64, blah 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 till the end, we don't even know when it ends, but do we know the sum? Yeah, it's equal to 2. Isn't it like, isn't it hard to think? Yeah, we don't even know. The series doesn't even stop. But how come we get the sum? Because when n gets bigger, what happens? This one will go to 0. Okay? Okay, that's why. The sum exists. Now, what about number 1? How would you do this? Well, same thing. We will write the terms. What is the, when I is equal to 1, what do I have? No, 3, right? Yeah. When I is equal to 2, what do I have? 3 over 4, okay. When I equals 3, what do I have? 3 over 16 plus dot dot dot, because it goes from 1 through infinity. All right. Yay or nay? Yay, okay. So now, do we know A1? 3. First term is 3. Do we know the R? 1/4. How do you get 1/4? 3 over 4 divided by 3. Yes, so this is 1/4. So 3 over 4 divided by 3 is the same as 3 over 4 multiplied by 1 over 3, right? Okay. So is 1/4 between between -1 and 1? Yes. So can I find the sum? All right. So S infinity is equal to A1 divided by 1 minus R. So A1 is 3. Oh, I forgot to write 3. So 3 divided by 1 minus 1/4. So this is 3 divided by 3 over 4. What is 3 divided by 3/4? What is it, 4? Yeah. Okay. So notice 3 plus 3/4 plus 3 16, blah, 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 blah. Is it equal to 4? Yeah. So a lot of weird things going on here. Yes? Okay. Can we do one more? And then that's it. Yeah. Doable? Yeah. Okay. So I'm just going to stay here so you can still copy. What is 12 plus, 12 plus, actually I was going to do minus 24. Minus 24 plus 48 minus 96 plus blah, blah, blah till the end. So those 3 ellipses, it means it goes on forever. So what is this? Doesn't exist? So let's see. This is the geometric series. What is A1? 12. What is R? -2. But then does R be between -1 and 1? So R is absolute value of R is greater than 1. So what is your conclusion? The series diverges, right? Or you could say the series, or you could say the series does not converge. Same thing. Now, when you get to calculus 2, you'll talk about these a lot. Yeah. The series diverges, the series converges, things like that. Why? Because you need to learn a little bit more about approximation. You know why calculus is interesting? Because of this. Look at this. If I want to find the area, do you know how to find the area of this rectangle? Yes. Yes. So what calculus does is, what about if I want to find the area of this? So then you start with approximation. Yeah. So calculus is really fun, actually. That should be your most fun class. So have a good weekend. What homework do you do Sunday? 11:2 and 11:3? Yeah? Okay. So Monday we will do 11:4 and review the sample. And I will send you the solution for chapter 11, but I do not have a lot. I think I probably have 10 or 12 questions from chapter 11. Okay, but I will send it to you today. Yeah? Through email like last time. Okay, guys, have a good weekend.
Would it be possible for me to switch days for that panel?
Wednesday?
Can I do it Monday? Yeah, Monday?
Monday, I think Monday is a holiday, isn't it? Or no, you can't do it on Monday. I don't have finals on Monday. You could do it on Tuesday or Wednesday. Do you want to do it on Wednesday? But Wednesday is from 12 to 2. No.
I'm going to do the DPS. That's why I was asking.
Oh, I see.
But
But
I can do it Monday.
so I have to send the final over there, right?
Mm-hmm.
You can't do it on Tuesday?
I mean, I could, but I've got more than one final that I'm going to all put into one day. So I can just do it everything in one day and get done with it.
Yeah, but I don't go to school on Monday, so I have to send it.
I can do Tuesday. I can have everything on Tuesday.
Tuesday? Okay. So there's what time?
DSPS opens up at 7:30.
I will be here on Tuesday at 9:30.
9:30.
Yeah. Is that okay?
Yeah, that'd be fine.
So they will pick it up for me?
Yeah, I'll have them come up to you and pick it up.
Okay. Sounds good.
I'll talk to you more about it when we get closer.
Yeah. Can you remind me?
Yes.
Because I might forget. Thank you. When did you send it?
No. I didn't send you an email. My email is different from the one.
Oh, can you send it again? Can you send me an email again?
Yeah, I'll send you.
Oh, okay. Okay, maybe I'll do it now. Yeah. If I find you, then you don't have to send it again. I'll do it now.
Okay.
Okay.
All right.
Thank you.
Thank you so much.
Yeah, you too. So your surface works fine. Can I see? Yeah. This is. Oh. Yeah. Hold on. Let me close the recording. So we're done with geometric sequence in 11.3. So next time we will start 11.4.